Welcome, my dear students. In today's class, we will talk about integration. If you remember, the last video was on differentiation, so today it's all about integration. So, to understand integration, firstly, you have to understand that integration is just the inverse of differentiation. Just the way when you have a positive sign and an equality that changes into negative, multiplication changes into division, the same way differentiation when goes to the other side would change to integration. You can definitely think of it like that. So just a positive changing to negative, the same way differentiation changing into integration. So whenever we are talking about integration, you may define integration between a particular limit. So, when you're integrating a function, you can integrate the function between a lower limit and an upper limit. That's x1 and x2. Then I represent it like y dx integral x1 to x2. What exactly does this mean? It means that I'm doing integration of y with respect to x in the interval x1 to x2. We can also talk about the graphical representation or graphical interpretation of integration. Well, let's say that I have a graph, okay, or I have a curve drawn between the y-axis and the x-axis, and I have the lower limit as x1 and the upper limit as x2. So I want to take in the area of this curve between the limits x1 to x2. So I can simply write that area as the integral of y with respect to dx, and the limits that I take are going from x1 to x2. In this, the only thing that you have to keep in mind is that your y has to be a function of x. So graphically, integration is just representing the area under the graph. You could also say that integration means the summation of very, very small parts, because when you have a graph which is a curve like this, then you want to take areas of small parts and then add them to get the total area. Now we have some rules or some basic formulae for integration that you should know about. If I want to integrate x to the power n with respect to dx, then my answer would be x to the power n plus 1 by n plus 1 plus there is a constant. This constant basically comes into play because of the initial values, since when you are integrating something, it's not necessary that you start integrating from 0. You can take it between any interval. That's why we have a constant. We will look at this constant a little bit more later when we are solving the questions. Let us look at an example over here. So suppose I have x square and I want to integrate it with respect to dx. Now if I use the power rule, n over here represents 2. So I will have x to the power 2 plus 1 upon 2 plus 1 plus my constant c. So that becomes x to the power 3 by 3 plus the constant. If I integrate 1 by x dx, then I will have ln x, that is natural log of x. The integral of sin x with respect to dx is minus cos x. The integral of cos x is sin x. The integration of secant square x dx is tan x, and plus constant. Constant is going to come with each one of these. Further, if you want to integrate cosecant square x dx, then that would simply give us cot x plus c. And then if I want to integrate tan x secant x dx, then that would give me secant x plus c. Suppose I want to integrate cot x cosecant x with respect to dx, then I would get minus cosecant x plus c. Lastly, if I want to integrate e to the power x dx, then the integral of that would just be e to the power x. So plus we have a constant, but then e to the power x integration just remains e to the power x. Now let us work on some examples. Let us apply all these rules or formula that you learned in some examples. So x square, I already integrated that on the previous slide. So x square dx integration you know is x cubed by 3 plus c, that is simply by using power rule. Next I have x to the power 6 dx, then you know the formula would be x to the power n plus 1 by n plus 1. So my answer becomes x to the power 7 by 7 plus c. The integration of just x means that it is x to the power 1 becomes x squared by 2 plus c. Then I have x to the power minus 4. So n over here is minus 4. So my answer would be x to the power minus 4 plus 1 by minus 4 plus 1. That becomes x to the power minus 3 by minus 3 plus the constant. Suppose I want to integrate a constant which is 5 with respect to dx. Now 5 you can take out of integration, but along with 5 I can write x to the power 0. Well, value of x to the power 0 is just 1. That doesn't change my 5, but that will help me integrate it. So x to the power 0 integration would just be x to the power 1 by 1 using the power rule. And then suppose you want to integrate 3x squared, then you take 3 out of integration, you integrate the x squared dx, which becomes x cubed. Just the way we had differentiation, like we had addition and subtraction rules in differentiation, the same way we have addition and subtraction rules for integration. Let's say I have y is equal to a plus b and I want to integrate this function y with respect to dx. So instead of y, I can write a plus b and I integrate it. Now this dx can go inside with a and b. So what I do is that I integrate a separately with dx and b separately with respect to dx and just add the two. Why add the two? Because there's a positive sign between a and b. So y dx integration would be equal to integration of a dx plus integration of b dx. Similarly, if I had a negative sign instead of positive, then I would integrate y with respect to dx. That would simply give me the integration of a dx minus the integration of b dx. We'll further look at some more examples here in order to understand this. So let's say I want to integrate sine x with respect to dx. Then you know sine x integration already by formula we have as cos x plus c. So it's minus cos x plus c. Now if you want to integrate cos 5x, okay, so here we will figure out our outer function and the inner function. So cos is my outer function and 5x is my inner function. Just like in differentiation we had the outer function, inner function, here also we have two separate entities. So directly by shortcut you can say, or a basic formula, what you do is that you integrate the outer function and simply divide it by the coefficient of x. This is a very basic shortcut, basic rule that you can keep it in mind because you are NEET students, right? You do not need to go into too much details, and as it is, mostly they are not asked. So we would simply integrate the outer function and divide it by the coefficient of x. So by heart this formula and use it wherever you see something with where you have a function with something like 5x, 10x, 20x, whatever. Then further over here at the bottom you can see I have a question where I want to integrate 4x to the power 6 minus 2x cubed plus 7x minus 4. So it's a basic thing, but plus and minus signs will follow the way they are and we will just integrate. So 4x to the power 6 becomes 4x to the power 7 by 7. 2x cube integration is 2x to the power 4 by 4. 7x integration is 7x square by 2, and minus 4 would become minus 4x plus the constant. So this is my integral. The second function, which is present below, you should try that yourself because it's pretty easy. You just use the power rule. Now, when we have been talking about integrals so far, all our answers were coming in terms of x because we were not putting in any limits. Okay, we were not defining the limits over there. So those sort of integrals are called indefinite integrals. You can have any interval there. But then comes in the definite integrals where we are only and only talking about a few particular or we are talking about a particular limit. So if you define a limit for your integral, then it would become a definite integral. So by definition, as you can see, suppose fx is a continuous function on a comma b. Also suppose that fx is any antiderivative for fx, then if you integrate fx dx between the interval a to b, then whatever is your answer of the integral, you take that and you take the limits as a and b. So first you substitute b, then you substitute a, and then subtract the 2. So this particular interval this particular integral you can see is being defined on the interval a to b. Let's try and do one example here and understand. Let's say I want to integrate x square plus 1 dx over the limit 0 to 2. Now we separate out x square and 1 dx and integrate it. X square integration would be x cube by 3 and 1 dx integration would just be x. Now I substitute the limit 2 and 0. So I would have, if I substitute 2 in the first one, x cube, 2 cube means 8. So 8 by 3 plus 2 minus 0. So further you can simplify this and this simply comes out to be 14 by 3. This is what the definite integrals give you. Definite integrals always give you constant answers, some fixed values of answers. Or what is the purpose of integration that we are teaching you, right? We are doing physics, but still I'm teaching you integration. So what does it mean? So we already know that if you want to find out the instantaneous velocity, we take the derivative of position with respect to time. And if you want to find out the acceleration, then we take the derivative of velocity with respect to time. You can substitute v as dx by dt and then you get the double derivative of position with respect to time. This is what we already learned in differentiation. Now, let us say that I want to find out, I have the velocity function already and I want to find out the position function. So I take dt to the other side and I have v dt equal to dx. If I integrate this with respect to time, or if I integrate velocity with respect to time between any interval, then I will get the position function. Similarly, if I have the acceleration function dv by dt and I take dt to the other side, then I can simply get that the integration of a dt will give me the velocity function. So velocity is the integration of acceleration with respect to time. If you want to define it between any particular limit, then you can take that particular interval, define it as your lower and the upper limit. Fine. If you want, you can also relate this to the graphs. If you remember, then if you have the velocity time graph, the area under the velocity time graph gives you displacement. That's the same as your position vector. And the area under the acceleration time graph gives you the change in velocity. So area is nothing but integral, and therefore when you integrate acceleration with respect to time, you get the velocity function. Okay, I hope you understand this. Now let us pick up an example here to understand this in more detail. So if the velocity of a particle is v equal to at plus bt square, where a and b are constants, then the distance traveled by it between 1 second and 2 seconds is given by. So I already know that the position vector would be the integral of the velocity function with respect to time between the interval t1 and t2. So over here my velocity function is at plus bt square and the interval that I want to take is between 1 to 2 seconds. So at integration would be at square by 2, bt square integration would be bt cube by 3. So over here I take the interval 2 and 1. So first I substitute 2 in place of t. So I have 2 square, that means 4a by 2 plus 8b by 3. Then if I substitute 1, I'll have minus a by 2 minus b by 3. So now if I simplify, 4a by 2 minus a by 2 becomes 3a by 2. 8b by 3 minus b by 3 becomes 7b by 3. So the correct option here is B. So all that we have done is we have just integrated the velocity function with respect to time to get position. Now let us look at another situation here. I have a particle p that moves on the x-axis at some time t seconds, and the velocity of p is v meters per second in the direction of x increasing. That means the position or the movement and the velocity, they are in the same direction, where v is equal to 60 minus 2t square. When t is 0, p is at the origin. Find the distance of p from O when p comes to the instantaneous rest after leaving O. Now, if I want to find out the distance or the position function, I have to integrate the velocity function with respect to time. V is given by 60 minus 2t square dt. So I get my x as integrate 60, I get 60 square. 2t square integration is 2t cube by 3. So my position function comes out to be 6t square by 2 minus 2t cube by 3. Now they said that we want to find the distance at a time when the instantaneous rest has been achieved. Instantaneous rest means that the velocity has to be 0. So using the velocity function, I can figure out at what time is my velocity coming to 0. So I substitute v as 0 and I get 0 is equal to 60 minus 2t square. So 2t square is equal to 60 or t is equal to 3 seconds. So at 3 seconds of time, my velocity was 0 or the object was at instantaneous rest. Therefore, I have to find the position at time t equal to 3 seconds. So now I take my position function, take the time as 3 seconds and find out the value. So I have 6 into 3 square by 2 minus 2 cube 2 into 3 cube by 3, and when I solve this you can see that I get 27 minus 18, which gives me the answer as 9 meters. So this is my final answer. This is the distance from P at which the instantaneous rest was achieved. So you can see that the questions are pretty easy and straightforward. All you have to do is integrate or differentiate depending on the demand of the question. So if you want to find out position from velocity, you integrate. If you want to find out velocity from acceleration, you integrate. Okay, so that's just a quick recap. So that's all for today. Thank you for watching and don't forget to subscribe to my channel.